Once again, to the official MUFON Podcast, I am your host, Richard Beckwith. My guest tonight is Marc Dantonio, the Chief Image Analyst for MUFON. He has a degree in astronomy and is the CEO of FX Models, a model-making and special effects company specializing in digital, physical models, and organic special effects in the film industry. He has done extensive work in the film and television arena, appearing regularly on a number of networks, including CNN, Discovery, Sci-Fi, History, National Geographic, and Science channels, performing on-camera work in his role as a UFO investigator, scientific principal presenter, and photo-video analyst. In addition to such roles, he has also created special effects props for use in some of these same productions, created computer-generated sequences, and set up and directed visual effects shots. Marc worked on seasons 1, 2, and 3 of NASA's Unexplained Files, creating science demos and discussion on the scientific search for life in the universe. Currently, Marc has teamed up with Academy Award-winning producer and director Douglas Trumbull to create major science fiction films and television series that explore humanity's place in the universe. I am very proud to welcome my friend, Marc Dantonio.
Hey, great to be here, Richard. How have you been?
Oh, I've been great. I really have, and I really appreciate you being here, Marc. I really do. I really feel lucky to have gotten to meet you and gotten to know you over the last couple of years, mostly as the result of the Devil's Tower UFO Rendezvous.
Remember that? That was a great time. We actually had a lot of really cool stuff happening out there.
Yeah, I really enjoyed that. I wish they'd do it more, and hopefully they will in the future. I would imagine they might do that in the future, but that's a fun little conference.
Yeah, it was.
Yeah. So you got a lot of stuff going on, don't you, Marc? In particular,
yeah,
you're setting up an observatory right now.
A second one, yeah. You know, I'm an astronomer. This is what we look like, you know. And when I got my degree in astronomy, you know, I started going into like the computer science masters and realized, yeah, I'm not going to do computer science. I want to do the outreach. I want to reach out to people because all the time I'm hearing people talk about astronomy and they're saying things that don't match what is scientifically credible and or correct. Now, I don't know everything, obviously, but I know enough to know when someone says things that are not correct. And seeing it so often, my thought was, you know what? Maybe I can just help a few people learn a little bit more about astronomy, and I'll be happy to do it. So how could I do that? Well, my friend John and I, John Zach, we decided we're going to get a telescope, and we're going to make it remote and available on the internet. That was a great idea. So we did a lot of tests. It worked great. Telescope's fantastic. And then unfortunately, John got sick and he passed away. And I was sort of dejected about all that and thought, well, there goes that idea. And I put the telescope basically in storage for several years. Then I had a health issue where I had to have surgery and it went sideways. And I ended up as profoundly blind and quadriplegic for a significantly longer period of time than I'd like to be. And I had to fight back and bring myself back. And when I did, I realized, you know what my therapy is going to be? Building this observatory. And so I hauled the telescope out after learning how to use my arms and get my strength back in my upper body. And I dug a pier hole out in my front yard, not the backyard, not out of the way, not hidden. No, there's a big round white minion on my front lawn that you can see for miles.
Not a zoning violation, I take it.
No, not in the farming community like there. And so I did that, and I bought a dome from a company in Canada because astronomers put telescopes in domes, I figured, right? Well, it's been working fine. But I'm going to convert it over to something a little different soon. However, then I said, I don't like being in this dome when it's 20 degrees out because my fingers were hurting, you know, because it's so cold. And I thought maybe there's a way that I can run it via Wi-Fi and be in the house. So I did that for a while using an iPad. I was controlling the whole telescope with an iPad. And I said, that's cool. I can take pictures with it. I can do this, do that. Then I thought, what if I what if I can move the telescope to somewhere where the sky is even better than here? I mean, here we have Milky Way, you can see Milky Way, but I've seen places where it's even better. So I started hunting and I found a few places and one of my friends who lives in the Arizona desert, a former Lawrence Livermore scientist, said, well, you can put it here. And I was like, bing. I went out there to visit. I looked at the site and I said, wow. And at night, the sheer number of stars you could see would literally make you be mesmerized. You'd stare at the sky and just, wow, look at this. And so I said, okay, that's it. I'm putting an observatory here. And I worked it out with them, with all the legalities, all that stuff. And now we're actually putting an observatory. In fact, today, while we're speaking right now, 4 walls have just gone up. I have pictures to prove it, in the desert. And they're all, it's being built right there today, and it's going to be finished tomorrow. And then I got to ship the equipment out, and then I'm going to go out there and install all the equipment. And we're going to have observatory number 2, because the one I have here, I'm keeping here. But out there, I'm building a second one. So I will have 2 places in the United States, one on each opposite end of the United States, where we can actually image the night sky. And what we do is we broadcast it to the world. And it's on YouTube. It's called Sky Tour, SkyTour, and then live stream, LIVESTREAM, Sky Tour live stream.
We've got that as a featured channel on our MUFON YouTube channel. That's our only
I'm
featured
so
channel.
grateful. I've actually gotten subscribers because of that. Thank you very much.
Good. I'm glad.
Yeah, very, very good. Thank you. And we show people things in the sky that they get to see in just seconds, not the typical minutes or even hours that it takes sometimes to acquire imagery. And many times I'll go in on a private night of my own, and I won't broadcast, but I'll just take lots and lots of imagery of certain things, and then I'll image process them and show them to people and put them up on our Facebook site, which is Sky Tour Livestream. And that kind of goes along hand in hand with, of course, my Facebook presence as well. And so people can see all the raw material, all the raw photos up there. They can download them. They can put them on their, do whatever they want with them. They're free on Facebook. We also offer a service where we can enlarge these photos to massive proportions. I can enlarge one of these photos we take to, something the size beyond the poster size. You can make it a wall size poster, so we have the resolution to do that. And if we do that, then of course we charge just a nominal fee. It's basically as much as it costs me to do it. I'm not going to make money on that, and I don't want to. I just want people to get these things. It's just cool stuff. Yeah. And they learn, because during the stream, Richard, what I'll do is I will tell people what they're looking at. From my astronomy background, oh yeah, this is a white dwarf. A white dwarf is a star that has, collapsed down beyond, used to burn hydrogen and helium, then it expanded into a red giant. And then when it started to run out, it slowly began to shrink down, and all that's left is that little hot core of the star. And it's literally really, really hot, and it continues to cause the nebula around it, all the former atmosphere of the star, to glow. I mean, all these things, they learn all about these things. And I tell them what everything is, how it happens, how it comes to be. And they like it. People really seem to enjoy it.
Well, speaking of these observatories that you have, I had a discussion with Lee Spiegel the other day, and I hope I'm not letting the cat out of the bag or anything, but he said something about you're perhaps producing 3-dimensional images, 3D images of astronomical objects, in particular maybe the moon, using those 2 locations.
Exactly so. That's right. We can't do a 3D image of something distant, but we can do a 3D image of the moon for the first time in human history, because we're going to have 2 identical telescopes 2,700 miles apart. Now, the moon is just over 2,000 miles across, but it's 240,000 miles away. Perfect distance to make a 3D image of the moon. So we're going to, for the first time, be able to actually produce a 3D image of the moon that'll actually be kind of cool.
Yeah, that sounds really neat. Now, this is going to, I suspect you'll be taking the photograph or the series of photographs on a night when the moon is full, right?
No, I don't think so, because when the moon is full, you get no contrast because the light is coming from behind you and hitting the moon, and it just reflects back. So everything looks flat. You do it when the sun is over there and you got this really sharp edge to the moon. You got that nice, what we call the Terminator, where light meets dark, right? And you do that from both coasts, and you're going to see a very different view.
Yeah. Now you work with Doug Trumbull.
Oh, yeah. Actually, you can't really, you sort of see it, that wheel back there. I move my thing, that wheel that you see kind of right here.
Yeah.
Okay. That's actually a special effects prop made of aluminum that I had made because we're actually working on a movie about Nikola Tesla. And that's a visual effects prop that we're going to be using. And Doug and I talked yesterday and the day before. I mean, the first time I met Doug, I thought he was going to fire me. But what happened was I was on an NPR show, and it was about the X-Files of Connecticut. Okay. And so when I got done, the host said to me, I got to get you on with Doug Trumbull next time. And I was like, Doug Trumbull? Doug Trumbull? Oh, that's like my idol. I can't believe it, Doug Trumbull. Oh, no, I worship the ground he walks on. The man did 2001: A Space Odyssey. He did Star Trek: The Commotion Pictures, I call it. He did Brainstorm. He did Silent Running with Bruce Dern and Huey, Dewey, and Louie, the Little Robots. He did Close Encounters of the Third Kind. He worked with Ridley Scott, for crying out loud, and Steven Spielberg, and how could you have me on with him? And the guy says, well, he lives in Massachusetts. So I was like, wow, really? I went back home and I looked him up and got his email, and I wrote him an email saying, listen, I'm so-and-so. I do photo and video work for the Mutual UFO Network. And I didn't even talk about my business. Okay, my business, because the thing was, by the way, the reason I was talking to Doug about that at all was because the host also said, he is a UFO hunter just like you. And he has a system to hunt for UFOs that he's working on. And I was like, wow. So I wrote an email about that. Well, you know how they say timing is everything, right? He gets the email and he reads it and immediately starts writing me back. And it was a 1.5 page email, okay, on my screen. Yeah, cool. 1.5 pages. I'm reading it, every word saying, Douglas Trumbull wrote this. Douglas Trumbull wrote. He said my name. He wrote my name. I mean, the guy. We model our visual effects work. I own a visual effects company. We model our work after Douglas Trumbull, and to have him contact me was just amazing. So he says, I went to your website, which I had forgotten I had in the link down below. I didn't even care. I was talking about UFOs. He says, excellent in every respect. He goes, we could use you right now on a project we're working on. Oh no, I think I had an accident, literally. Sure. So he said, can you come up today? I was like, yes, yes, I can come up anytime you want. Okay. So I go up there and I'm immediately impressed with the number of buildings he has up there. And it's basically a Skunk Works of movie making. A Skunk Works. Basically, he says,
oh my gosh.
You experiment here. He says, we experiment. We don't actually use tried and true techniques much. We actually create our own. Wow, that's exactly the kind of thing that I'm into. So my first exposure to working with him professionally was working with him on a Burger King commercial. Now, he hates commercials. He doesn't want to do that kind of commercial work at all. But he looked at it as a stepping stone to get a team back together and see who would work and who wouldn't. And there were some people that did not, and there were some people that did. Now, I thought on my first day there that I was going to be one of those that did not work. And the reason was my job that I was hired for, there was a scene in this Burger King commercial where these giant Oreo cookies, which were supposed to look like small Oreo cookies. I had to make big 3.5-inch diameter Oreo cookies. Okay? And they had to be made of a breakaway material. Now, this is what you're given. I want Oreo cookies this big that break away when if you pat them, they'll crumble. That's it. Go figure it out. I love it. That's the best stuff. That's the kind of stuff you want to do. So I figured out a way to do it. And my first run of the cookies didn't really work so well. So I had to go and modify all the 300 that I made. 300 that I made.
Non-edible, I take it.
Non-edible. They were made of plaster and vermiculite and special material that would shatter on impact. And what's funny is they were going to be flung by catapults that were spring-loaded catapults. It would fire a cookie this way, one would fire a cookie that way, and one would come up from the other side and kind of shoot it back. So they'd all meet in the middle. In the middle of the camera frame was where they all had to meet, and they collide, and that was the shot. All 3 cookies coming from 3 different directions, bam, and they just pulverize each other. All right? That's how it was supposed to look. So I looked at the catapults, and we launched a wooden puck that was the same weight, all right, and size as one of the cookies, all right? And it went a pitiful 1.5 feet. It didn't even barely make the end of the catapult because the spring that was being used was nowhere near strong enough. So Doug comes in. How's it going in here? And of course I'm like, hi, Mr. Trumbull.
I'll pack my things now.
No, not yet. No. So that's fine, okay? We can always improve, right? I go, yeah, the spring, it wasn't strong enough. And I looked down on the floor and I saw surgical tubing, a big roll of it. And I said, can we use the surgical tubing and maybe make it a little stronger? He goes, hey, that's a good idea. Yeah, do that. I'll come back in a little while and check out. How you doing? He walks out, and all I heard was, good idea, directed at me. Douglas Trumbull, Academy Award winner, said I had a good idea. That's what I'm hearing. That's what I heard. I didn't hear anything else. He could have said, oh, my gosh, the roof is collapsing. I wouldn't have heard it. I'd be covered in rubble. Okay? So anyway, I get the surgical tubing out, and Doug's son is working with me, and I wrap the catapult, wrap it up, and we have it on this latch, and it's an electronic release because you have to do this electronic release. We do a test, all right, without anything on it, and it goes, phew. I mean, it went so hard that he said, yeah, I don't know. That seems a little too strong. And me, Mr. Big Shot here, is saying, nah, that's not strong. I think that'll be fine. He goes, I don't know. Oh, yeah, it'll be fine. And he goes, are you going to test with one of those wooden pucks, one of the replacements, the like material? I go, yeah, let's do that. We put one on there. He sets it off, and I didn't see it go, but I heard it hit. It hit the garage door, and it made such a loud bang and put such a big dent in Douglas Trumbull's Academy Award winner studio garage door that I heard him out in the parking lot yelling, like, what the beep was that? And I hear him tromping around. He comes into this place, into the little studio space we were working, and I'm thinking, I'm so fired. I'm so fired. And Doug says, what the hell happened? What's going on? I said, the catapult, the cord, I can't even speak, Doug. The surgical tubing was too strong. And he says, so you did that? And I go, yeah. And I look to my left, and his son's pointing at my head like this, like, like pointing, yeah. Yeah, he did it. Okay. And I thought I was going to be told, okay, you're done after today or whatever. Instead, he looks at me and he goes, that's an excellent idea. Just tone it down a little and save my garage. He goes, good job. And he walks out, and I'm going, I'm so not fired. And for the last 6-7 years, Doug and I have been very good friends. We've done a lot of work together, and I've been consulting with him and working with him, designing visual effects like crazy. And when he has projects, when he doesn't have projects, I have my own company, and I've got Navy work I have to do a lot. So,
yeah, you build models. That's why you have a company called FX Models, right?
That's correct. Yeah, FX is the colloquial, FX, visual FX, FX.
Sure.
So yeah, FX models, and we built a lot of submarine models. Anything below the water and up in space, it seems that's where I belong. On the Earth, not so much, but up in space and down in the water, I'm cool, So with that said, I've been able to balance that life doing that work and then doing this work with Doug. But Doug always has the coolest projects, and he calls me his chief scientist, which I think is hilarious. Okay, because I'm the guy with the degree in astronomy, right? So he always runs things by me. It doesn't always work, though. My thoughts of like hypercooling with liquid nitrogen a pane of glass so that it will shatter brilliantly on impact with a ball bearing or something didn't work so much. It strengthened the glass. What did I know? I read the material wrong or something, but it still works well, and it still works out well, and we get along very well.
What about UFOTOG? This is the...
Well, yeah. The UFOTOG was Doug's original design with a Humvee where the top would open up, okay, and on a pedestal, a big hydraulic mount, this giant arsenal.
Those are the dogs I was telling you about.
And then the Humvee would open up, and on this pedestal of telescopes that would rise on this hydraulic lift, he would tune them in to look at the sky and be able to detect motion, and then it would seek out and find motion anywhere in the sky. And in an effort to try and find, interlopers that might be entering our atmosphere. They could be meteors, they could be jets. In fact, they would often be jets. Okay. Well, bottom line is, Doug, spent a lot of money to make that one singular Humvee, and it could not go in certain places. It couldn't be deployed to a mountaintop somewhere if there wasn't the road. So we sat down together, and he said, "I'm really frustrated with this whole UFOTOG thing." He goes, "Because it's one vehicle, and I said, "I have an idea." And he goes, "You probably have the same idea I have." And he did. I wanted to make these small little platters that might be round, maybe 24 inches or more across. And they would be covered with instrumentation that would be able to report all kinds of things that it sees in the sky, measure distances by conferring with another unit nearby and do the triangulation and figure it all out. And he really liked the idea. And we started UFOTOG 2, which we renamed to the Aerial Anomaly Detection System, the AADS. Now, why would we do that, Richard? Because every time you put UFO in the name of your thing, people run for the hills.
Right.
The AADS, is something that anyone can sink their teeth into. They can sink their teeth into this because of the fact that the AADS would be something that can detect errant asteroids. It could detect anomalous aircraft. It could detect UFO things. It could detect anything. And amongst those, it could detect, aerial interlopers that are using advanced technology and advanced propulsion. So the idea, as I've always said, and every 15-year-old loves it when I say it, the Aerial Anomaly Detection System is designed to detect the skid marks of an alien race that are using advanced propulsion in our local universe.
Let me ask you about that, Mark, because when we, I think, last saw each other, we had this was in September, I think, of 2018, when we were at the Devil's Tower UFO Rendezvous, and it was just that previous January, December of 2017 when the ATIP videos came out. And so,
that's right.
And so, have you looked into that at all? And have you drawn any conclusions about the nature of these objects, at least in terms of observing them, and any conclusions you've drawn about maybe the propulsion technology or what they might be?
Right, a very good question, though, Richard. And I'll tell you, I've looked at all the videos. In fact, I was asked to examine all the videos, and I wrote a white paper for MUFON on them. What was released didn't have anything on it that was heartbreaking, heart pounding. It wasn't anything that got you to stay up at night. The video that was released didn't have anything that was exciting enough to be definitively labeled out of this world. In fact, I was able to detect that some of what we saw were due to the mechanics of the system taking the imagery. There was one called the gimbal, and you see this thing rotating, and you hear the weapons officer go, "Look, it's rotating." Okay, what was rotating was the lens flare, the infrared flare, created by the camera filter that was rotating in front of the sensor on the AT FLIR pod on the Hornet. And I recreated it to show that I'm not just making stuff up. I said, look, here's how it works. And I had a filter, and I showed how when you turn the filter, because of the way the filter's lines are, so to speak, it'll cause this thing to rotate as well. The lens flare will rotate. So I felt that the rotation wasn't the thing that should be calling it, that we should be calling it a UFO with. And if that wasn't enough, in that same video, every single time it rotates, all the clouds also in the shot bounce a little, which tells you it's systemic to the system. It's an internal artifact caused by the system. Rotation is doing this. Okay. They're tied together. No, the UFO is not making the entire Earth bounce up and down. Okay. It's a filter that is doing this as it's rotating. And whatever's rotating in front of that sensor at that time caused this bounce. As the object that's seen in the field of view, as the weapons officer says, oh, it's rotating, and you see those spikes sticking off of it. Those spikes are an artifact. Those spikes are due to the gain, or it's a flare, a lens flare from this infrared camera. All right. This is not abnormal stuff. I have infrared cameras on drones actually here, and they do the same thing. They cause hot spots that can be overblown. We call those blooms, but most of these have gates, what are called gates, to pretend to protect from those blooms. If that doesn't happen, you'll actually see that spike. For whatever reason, in this case, it didn't. And every time that rotation occurred, every time you saw those little spikes moving, the cloud bank that you could also see was bouncing slightly every time. It was a discrete set of motions. Click, 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 click. Now, why is this bouncing? Why is this cloud bank bouncing when this is moving? It's because this whole appearance, everything you're seeing, is inside the infrared pod. Something inside the pod was moving that caused this entire scene to bounce a little bit. The entire scene bounced, and moved, not just the reflection or flare rotating. So you ask the question, what is this? What are these things? Well, that right there, in that particular one, I was actually able to superimpose another F-18 Hornet into the shot and size it appropriately for the size of the two hot spots that would be for a Hornet at that point. And there was a couple times, not a lot, but only like 2 frames of all the frames where it actually looked like it matched the Hornet. So could that have been a different incident, and that was just one of the combat air patrol aircraft? Maybe. It's possible. Maybe they had the wrong footage. But here's the thing I don't doubt. I don't doubt what the pilots say. These guys are not prone to flights of fancy. When they tell you something happened, it happened.
I agree.
But what you see isn't necessarily what they saw. In fact, when Dave Fravor talks about these things, all the footage you saw in ATIP were none of his.
Yeah, they came later that day.
Yeah. Right. See, so there's really no, that's the problem. People are like conflating it all to be the same thing. Oh, he's talking about it. Look, there it is. He said this is it. No, he didn't. Right. Okay. He saw something different.
And your job was merely to analyze the images, not to identify the objects in the images. Well, certainly if you could determine what they were based on your analysis, you would say so. But that was not your job. Your job was simply to look at the images and make a determination about how exactly the images were made. Were they made by something from another world? How would you ever be able to tell that?
Well, the way I'd be able to tell that is by doing everything I do, which is to rigorously put things through a funnel, of processing. And if at the end of that processing funnel, and there's exit points all along that funnel where all the knowns are. Okay, well, this is just a ship. This is just that. This is just a star. This is just this. This is just a bird in flight, blah, blah, blah. If down through that funnel, you get down to the bottom, if nothing comes out, you have a true unknown. All right. I'm sorry. If nothing comes out, you have a known. If something comes out, well, that is the true unknown. If it makes it through all that rigorous testing and it still comes out, then you have a true unknown.
Once you have eliminated all but the impossible, all that remains, no matter how improbable, must be the truth.
That's
Sir
correct.
Arthur Conan Doyle.
That's right. That's right. And
so,
I operate on that
and
same.
Your funnel was just the video, just the image funnel. Yeah, that was the only funnel you were given. You weren't really given the whole project funnel. Just what do you see in these images?
Yeah, that's all I saw was in those videos. Yeah, and the videos didn't tell the story that the pilots and the other people that were in the situation were telling, and that's the part that is telling. Okay. Clearly, what was released and what they saw were two different things. And I accept that. I know the people. I know Kevin Day. I know a lot of people there. I know people that were on the ships. I know people that were in the air. I talk to them, spend time with them. Again, they're not prone to flights of fancy, and admitting this stuff has really damaged their lives. So they're not, I don't know why. I mean, having an open mind is part of why I'm what I do. As an astronomer, I'm supposed to be tied to academia. I'm supposed to be only spouting the quote unquote company line in astronomy, right? I'm not supposed to be able to go and speculate. Yet I do it all the time. Why? Because I think that there is extraterrestrial life out there. I mean, that's what my book's about, is finding life in the universe based on the fact that everywhere we look, we see the building blocks of life. Everywhere. And there's even more exotic places that life could exist in the universe. And some of them we might just be finding now. The planet Venus has always been, that's our sister planet, yay, except it's not. Sulfuric acid clouds, 900-degree temperatures, 90 times denser atmosphere, crushing pressures on the surface. Yet they found phosphenes in the atmosphere of Venus. Okay, what's phosphine gas? Phosphine is a phosphorus and 3 hydrogens, okay, pH 3. Well, what does that mean? It means that particular gas is usually made in the presence of life. So wait a minute. Either some exotic chemistry we don't understand is at play, which could be true, or there's some kind of life forms on Venus in the microbial world.
Maybe
that are alive,
in the atmospheric
floating
bacteria,
in the atmosphere.
Perhaps.
That's correct. And they might be creating this phosphine gas.
Now, you're the astronomer, so you tell me if I'm wrong about this, but my understanding is that the upper atmosphere of Venus is considerably cooler and much more hospitable than Venus, the surface of Venus, and it actually even perhaps mirrors or is somewhat closer to our own atmosphere at a certain distance from the surface.
You can draw a rough parallel, but yes, you're correct. And that is, again, we know that life that we know of doesn't like acids. We know life doesn't like sulfuric acid, especially if it's concentrated, right? We know that organic compounds, molecules break apart, skin dissolves, basically, if we do that. Yeah. We know we're made of carbon, and carbon is everywhere in the universe, and carbon can bond with more things than anything else. Carbon, it has 4 places on it, and it can bond with something. You can make compounds with 4 different connection points. That's rare. The only other one is silicon, okay? And silicon is actually not as hardy as carbon. So if we're going to find life in the universe, it's probably going to be carbon-based. Every life form on Earth is carbon-based. Yeah.
You just reminded me of something. I did my background's in molecular biology, and I was working for a soil microbiology lab, and I actually worked as a microbiologist, as the microbiologist, the chief microbiologist on this selenium leaching study. And what we were doing was taking samples from various levels in the soil to determine how much selenium was in the soil and how much leaching was taking place, and to determine if there were any organisms associated with that. And I tell you, Mark, I discovered an organism. I didn't classify it or name it or anything like that, but I discovered a bacteria that appeared to live on selenium. I know that sounds crazy, but I actually isolated a strain of bacteria that these colonies would turn bright red because I was feeding them like a 75% selenium solution, and these bacteria were eating it and thriving.
Yeah. See, now, again, that I don't find that to be outrageous at all. I mean, consider the fact that down in the deep ocean, right, there is life at these sulfide chimneys, okay? We call them the black smokers colloquially. I have a piece of a black smoker here, actually, that I was given by someone from the Woods Hole Oceanographic Institution. And these chimneys are the result of, and this ties into what you're saying, the result of water being pressed firmly down into the ocean floor by the weight of the water above through fissures and cracks in the ocean floor, seeps way down, then it comes back up, laden with amazing minerals. And there's bacteria down there that feed on these minerals. and there's methane coming out, obviously, and they feed on that as well. Well, those bacteria bloom in the finest way. The bacteria bloom around these smoker vents. And of course, there's other creatures that filter feed the bacteria and eat them. And then there's creatures that eat the filter feeders. And it kind of goes up the food chain a little bit. So each smoker, each black smoker, the sulfide chimney, which is over a hot spot in the Earth's mantle, as the Earth's tectonic plate is moving along, these little hot spots pop up. And these hot spots are where these sulfide chimneys will show up. So as the Earth's tectonic plate moves over millions of years, you can see all these dead smoker sites all along in a line along the direction of movement of the plate. So this tells you that there was oases of life way back when. Now, there's no light that gets down there. And on the surface, we know very well, as you do, that life is photosynthetic at the surface for the most part, right? The basis of oxygen in our atmosphere is photosynthesis, right?
Right.
But wait, what about down in the deep ocean? You know, and now everybody else will know, if they haven't already, that it's chemosynthesis.
That's right.
It's chemical synthesis of energy for life. Okay? That's what those creatures are doing down there. So
water, but there's water there. And so the question I have for you, Mark, as an exoplanet expert is water necessary for life? Can we have a living biosphere wherein maybe it's not carbon-based life forms, but some other form of life that doesn't require liquid water?
The answer to that is a surprising yes, possibly. Tell you why. It's possible that silicon-based life could exist, for instance, on Saturn's moon Titan. Lakes of ethane, okay, that's not water. Okay, methane lakes, methane rain. Okay, well, silicon-based life could exist there potentially because it could thrive in those conditions, you know. But maybe if we're looking for the carbon-based life that we're so, well, I'm a carbon chauvinist. Do I look it? I'm sorry.
Yeah.
I'm a carbon bigot. What can I say? You can say I'm prejudiced. You're racist toward carbon. Yes, I am. I'm a carbon racist bigot. Call me what you will.
You're a carbonite. You're an anti-carbonite.
Oh no, carbonite. No, that's something else. Yeah. No, but yes, you're right. Being a carbon bigot has its price, that you have to pay. And it means that you tend to proselytize that carbon is probably the basis of life in the universe because carbon's so ubiquitous, it's everywhere. It has so many ways to bond. It bonds with more things than anything else. It's called the granddaddy of elements in the periodic table. It's a magical place. But still, when you consider that carbon, life forms on this planet, well, you were a microbiologist. You are a microbiologist. You know this. Every life form on this planet has DNA. And the DNA is, of course, built on carbon. And that carbon, it goes more than that. The basis of life is something I call chomps. You know what chomps is?
Oxygen, phosphorus, sulfur, and magnesium, right? Or nitrogen, phosphorus, and sulfur.
You're right. You got it. Good job. You got carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur.
I'm glad I got that right because I used to say chomps all the time before I was taking it.
Yeah, that's where the M would go magnesium, right? Yeah, I know. Right. Yeah, N is for nitrogen. You got it. But you see the point. And to those listening, chomps is just basically the basis. You think of it as the basis of DNA and all life structures on this planet. And it's a natural template provided by the universe. When the Earth was young and molten, the Earth began to make the building blocks of life. We know this through an experiment done called the Miller-Urey experiment, and was it 1950 or 1952? And they made they set up basically the primordial atmosphere of the Earth. And of course, that's tricky because we're not really sure what was there. But based on the different concoctions they came up with, they still got a result which led to the creation of amino acids, which are the building blocks of life in this little flask at the end of the week that they did this testing. Now, what they did was,
right? They were
exactly exactly right. They created lightning strikes, basically, and these lightning strikes were in this ball flask. They actually put electrodes, and it just went a spark gap. And at the end of the week, there was this black tarry material on the bottom. What was that? Well, amino acids. And then 50 years later, they dug through these again, and guess what? They found 22 additional amino acids they could not detect at the time. Those are the building blocks of life. Those are the building blocks that make chumps work here. So we know that the Earth itself creates the building blocks of life. And they're also delivered by meteorites. They're delivered by comets. They're delivered by asteroids, right, that have struck the Earth over the many billions of years it's been here, okay? So that said, we know that this means the universe is providing what amounts to me as a template for life here. And that template is carbon-based. It's a carbon template. Carbon bigot that I am.
Right.
I am open to other possibilities, but silicon is just not very robust, is the best word, I guess, compared to carbon.
Or versatile, perhaps. It can certainly bind with other elements, but not as readily as carbon.
Exactly, and it can't make as many different types of compounds as carbon can. So it turns out that carbon is the magic element. It's sort of a little bit of magic, that the universe created. So that is where, in my view, we should be focusing, is trying to at least find other life like us. Yeah. Now, like us doesn't mean humans. Okay, we're the product of 5 major extinction events, and we kind of squirted out one little side to see, this is kind of how we turned out because of the basis of evolution and what it's done to us. Mm-hmm. Our chemical content, basically the salinity in our bodies is basically a vestigial ocean we carry around with us, right? Mm-hmm. And we're only a few percent salt, and it's a lot less than the ocean, but that is the vestigial dependence on sodium that we're showing with our construction. So when people say, well, maybe we were planted here by Panspermia, well, maybe so. It's possible. Martian meteorites could have landed here with amino acids and with other stuff that could have been the building blocks of life, but it doesn't have to have been that way because the Earth generated a lot of them itself, and we see them all the time. So yes, Panspermia could also have contributed, but it would have had to have happened way back in the beginning
of life.
Way back in the beginning of any life. Yeah.
When I hear people say, well, perhaps, we were brought here by some other race, my response to that is right up the alley that you're walking, which is, well, we're so intimately chemically tied to this planet. We're biologically tied to it. All you have to do is look into the chemistry in our bodies. We have genes in our DNA
that's right.
that are so highly conserved that we share them with plants.
Yeah, that's right. Yeah, that's right. And when you look at how our DNA differs from some of the animals, it really doesn't differ that greatly. It's only in those final few percents that make the difference between us and other creatures. So yeah, we are dependent. So if Panspermia occurred, it would have had to have happened way back before we were us. It would have had to have happened when we were still primordial ooze. Okay? And that's something that I'm okay with. I really am. I just think that when you consider how evolution has changed all the life forms on this planet, it's incredible. 250 million years ago was the Permian period. Now, back then, at the beginning of the Permian, the oxygen content in the atmosphere was 30%. It's 21% today, but 30%. So, life abounded. Life abounded in the oceans and everywhere. But then something drastic happened, and we lost 96% of all ocean life and 70% of all land life. How did that happen? Well, the best guess we have right now is from a massive, globally massive volcanic eruption that occurred in what we call now the Siberian Traps. Okay. This area basically was a cap over a very large magma chamber. This magma chamber was pumping lava up, and as it cooled on the surface, it formed this cap that went out for miles and miles and miles and miles. And then the lava began to move horizontally, creating what are called dikes, right? And they went up to the edge. And over time, as it went through other materials, this lava oozed through other materials over thousands and thousands of years, it encountered lots of organic compounds in the soils. And it converted that over to carbon dioxide, all right? And that carbon dioxide was now traveling along in solution with this magma that was under the ground. But when it reached the edges, and this is simplified, when it reached the edges of this cap, it burst forth. And because it was moving radially, they seemed to think that it might have happened all at once, we ended up with well over, I think it was 30 gigatons of carbon dioxide in the atmosphere in short order. And that caused the atmosphere to get not only thicker, but it caused a reduction in oxygen in the oceans because the temperature rose on the planet about 21 degrees Fahrenheit.
Wow.
Okay. And that was in very short order. Now we're talking in a couple of weeks. That's incredible. That spelled doom for most creatures on the planet, actually. Mm-hmm. And it spelled doom for most creatures on the planet. Not surprisingly, but the creatures that weathered that good, Richard, were the reptiles, the pre-mammals, the things that would eventually become us. Okay. They were most affected by this. And they basically were wiped out or went into hiding, genetically. And they ended up not being dominant anymore. They were the dominant life form back then, which is another template that the universe seems to provide for. Mammalian life seems to be a direction based on us only. And that one's a stretch. We talk about life as a template. Well, that's fine. But mammalian life, the jury's out, and I don't make any pronouncements really. But it does seem interesting.
But then basically structural things too. I think that bilateral symmetry may be
that's
favored,
right. Yeah, in fact, I didn't mention that, but I mentioned that in all my talks. Yeah, bilateral symmetry is in all life. Or I should say, symmetry is in all life. Oddly enough, people say, "What about starfish?" Okay, yeah, that's pentamerism. That's five-sided. I get that, but you know what? As a larva, starfish are bilaterally symmetric. Oops. But that doesn't mean all creatures are. Tulips aren't, okay? There's flowers that aren't. And that's radial symmetry of some sort, right? Depending on how many. And that's fine. But it's all symmetric. And it has to do, I believe, with the way DNA replicates. Think about how DNA gets replicated. It unzips, and I have this strand called RNA. Mm-hmm. RNA goes off to a place in the cell where another strand, identical copy, zipped up on the other side. The complementary copy is zipped up on the other side. That's symmetry. Okay, double helix is symmetric. It's not a 2.5 helix. It's not a quadruple trinary, somewhat sort of helix. It's a double helix, right? So that might have something to do with the symmetry. And I bet you have plenty to say on that.
Yeah, well, a little bit. Not right now, though, because I'm interviewing you.
Oh, but still, I'm interested in what you have to say. My gosh.
Well, I do think bilateral symmetry is probably pervasive throughout any place in the universe where life abounds. You would think that bilateral symmetry would be highly adaptive in terms of being able to move quickly, to stand erect, to see what is coming at you. I don't know about how many eyes. I don't know.
Binocular vision is important, yeah. Right. And for those that don't know, incidentally, bilateral symmetry is being the same on both sides.
That's right.
Okay, we're kind of like that. Yes, we have subtle differences, but I make a distinction here when I talk about this. We're bilaterally symmetric with the way we interact with the environment, not with the way our organs are laid out. Okay. Yes, we have 2 lungs, but we have 1 spleen. Okay. We have 1 liver. Okay. And there's multiple lobes. Okay. But the thing is, with the way that we actually physically interact with our environment, the way we carry on, the way the environment can affect us is going to be through a bilaterally symmetric being. And I talk about this often, and people can't wait for me to say this. Otherwise, we would have pogo stick cows bouncing around, on the earth. We'd have one-legged creatures, right? We don't. And an inchworm doesn't count. If you look at an inchworm really closely, it's actually bilaterally symmetric down there.
Sure.
So, yeah.
So let's talk about aliens for a second.
Oh yeah.
So, and let's fast forward a few billion years, and let's talk about the analysis you've done of images of the moon and Mars. And I want to know if now, I'm not asking you if you've found aliens on the moon or Mars. You've been in some television programs where you've discussed things that you've seen, but have you seen things on the moon? Have you analyzed images from the moon that you would look at? Have you looked at that and said that might be artificial?
I've seen the typical YouTube videos you see. As far as the moon goes, there's only one image I've ever seen that I felt needed some explanation. All right. And that was something called the shard. Now, it was looked like a tower thing, but it looked to me like a geyser erupting some kind of gas. But the moon's been long dead. So the question is, tectonically, since the moon is dead, and volcanically, since it appears the moon is dead, what would that have been? Something captured, by effectively modern cameras. I don't know what that was, but I'm guessing it was probably something that might have been natural. But I think that was pretty cool. Actually, there's a second one. I did do a show called Aliens on the Moon. I was part of that. It was done by Bob Kiviat, a good guy. He's just trying to get to the truth. He's going to flair for the dramatic, of course. And of all the imagery that I analyzed that he provided, there was only one that I didn't say or could say was either a mistake, trick of light and shadow, because what I did was I actually recreated these things. I didn't just make pronouncements, oh, that's just light and shadow. I would actually go into my visual effects shop and I would actually create the actual situation. And I would make it. I have moon dust that I made, which actually mimics the lunar soil in both its static properties, clingy properties, clumping properties. It's something I spent months developing, and I can make it. Isn't it great? He makes moon dust. And the only thing I don't do is I don't give it that glass, content that would be necessary to make it true moon dust. Because then anytime you make a crater with it, which we always use it for doing cratering stuff, you do a crater with it, and it'll fill the room with this very, very fine powder. Well, that would be very fine glass, right. In the lunar environment. We don't want to do that. So I left that out, and that does cause a difference. That causes a difference in the way it reacts, but it's not enough to worry about. So I would show, I'd say, look, here's my setup for how this particular image was taken. And we'll change the light. And I had lights that did all this stuff to show them how things would change on the moon. And basically, in one case, I was actually told by the producer who was here, he looked at me and said, because I fully explained it it was an actual trick of light and shadow. Okay. And he goes, yeah, that won't make it into the show. I go, well, but that's what happened. He goes, yeah, it's not going to make it. And we want that to be a mystery. So you're up against that. Okay.
Sure.
But it's my reputation that's on the line. See, so I basically said, okay, well then don't include me in that segment because that's not what I'm saying. Mm-hmm. Okay. Good. I'm not going to say it's not,
a man of integrity.
Well, thank you. I do know that, science doesn't have an ego. Okay.
The answer is the answer.
That's right. You either science or you don't.
And whether you like it or not is irrelevant.
That's right. And whether it works for me or doesn't is irrelevant, Well,
let's go to Mars. Anything on Mars that's made you, we all know about the face. I've given up on I gave up on the face decades ago.
Yeah, that I understand. Yeah. But you're right. Mars is a different place. And on Mars, I wasn't looking for, as you see on some of the YouTube videos, which I think they're fanciful, if not entertaining. But when I look at some of these videos, okay, you see how they're altering the facts to suit what they want you to know about, or make you think about. We think this is life on Mars, and they show this close up of an image, and it looks geometric. Ooh, geometry, people say. Yeah, except that with the compression algorithms that are applied to these images, if you zoom in enough, they're all going to look rectilinear. It happens on everything on the moon, okay? And there's a lot of that going around, And for heaven's sake, don't use Google Mars. Don't use Google Moon. That is not going to help you because those images are really low res. They're very, very compressed. And you'll see what you want to see if you're looking for construction. So you'll make it happen, I'm sure. Mm-hmm. But it isn't. You're not looking at real data. You're just spinning your wheels. Now, on Mars, though, I remember, again, I did something that's kind of sort of esoteric and maybe boring. I started going through every daily image that Curiosity was delivering. Okay, the Curiosity rover. We're quite a ways past our warranty on that, by the way. It landed in 2012, and it was only supposed to last 90 days. I think we're doing okay.
Yeah, we should have got a big bang for our buck on that deal.
Yeah, you think so? It's like, do we still have to run this thing? Jeez, really? Okay, we're up for another year. Woohoo! No, but they love it, actually. It's great stuff. Well, anyway, Curiosity used a special tool called the RAT, the rock abrasion tool, and it was grinding away at something and then sending those images off to NASA where they get uploaded to a server. I was looking at that server and I was watching as the daily images were coming in. And for all the world, I thought I saw something called a crinoid, where it had abraded, and I saw this ridged, segmented looking. It was about, in reality, it was only about that long, about maybe less than an inch, okay? But it had segments in it, okay, that were like wider, shorter, wider, shorter, wider, shorter, like that, all the way down its length. And I went, that's a crinoid. Holy cow, they found something. They found a crinoid. Because they had ground down to it, potentially, is my thought. And I basically tried to find out if that image was an image they or an object that they kept. Did they finish drilling with the rat? Or was that just an intermediate object and they just went right through it, and went on to something else? Turns out they went right through it and on to something else. And they've never had another one since. And there are people saying, oh, NASA's hiding. No, it's not. NASA's not hiding anything. You know why? Because every mission to Mars, every single mission to Mars has as its main tenet, look for signs past or present of life on Mars. That's the whole mission. That's their mission, So, they're not going to hide it. And to what end? To what end? That's silly. That's conspiracy. That's people saying, I'll make an internet video and put it on YouTube and get 1 million hits. Okay, I'll make a viral video that says life found on Mars and they destroyed it. Not true.
Let's talk a little bit before we go about, and I'm sure you're familiar with this experiment. It was when we sent I think it was Mariner, and this probe had an experiment that went along with it. This was the probe that landed on Mars, right? Is that the name of the probe, Mariner? Was it the?
Mariner was early. It never landed. Mariner was just a satellite that kind of orbited Mars that we sent. It gave us the first images of Mars, the Mariner missions.
Well, there was a mission. I think it was the first mission to land on Mars, and there was an experiment on that particular.
That would have been Viking.
The Viking lander. That's what it was, the Viking lander. Okay.
And you're talking about the oven they had to try and bake.
Exactly. And so that guy designed it, from a biological perspective, to me, a very simple, straightforward experiment where he put some medium on a dish with some radioactive marker in it. And he sent this experiment to Mars thinking that they'll dump a little bit of soil in there, and if there's life on it, they'll start to eat this medium and it'll release some of the radioactivity in this medium. And they actually got results, but then later the results were dismissed. Do you think there was anything to those positive results? They certainly, the peak in the radiation seemed to take place during the circadian rhythms of Mars. They seem to follow that rhythm. Do you have any conclusions about whether or not they might have actually found something, whether or not there was something alive on that Petri dish?
Well, they actually went back and looked at this experiment in later years, and they felt that back then we didn't have the technology to adequately detect it. We couldn't adequately do it. However, they felt that those results were now called into question, meaning maybe they weren't negative results after all.
Yeah, and they were positive results. I think that's the guy that designed the experiment said, no, it worked. There was life there, but we can't draw that conclusion because we don't have the instrumentation necessary to make that.
It was too crude. It was too crude at the time. Now, we have radars that can actually do looks underneath the surface of Mars. And we found a lake under the south pole of Mars of actual liquid water under the lake, under Mars, under that south pole. Now, Mars is really cold. Mars is desolate. Mars is arid on the surface, okay? But if you go up north or south, you find lots of water locked up as permanent ice at this point, right? And lots of CO2 ice as well, because 98% of Mars' atmosphere is CO2, carbon dioxide. And so when it gets cold enough, that carbon dioxide can rain out as snow, and you get like these frosts of carbon dioxide ice. Well, on Mars, looking in the South Pole, they discovered that there was, using this ground penetrating radar from orbit, they found that there was this lake. I think it's about a kilometer underneath Mars' surface, and it's about 12 kilometers long, so roughly. Well, if it's liquid water, then you know that it's being held at a certain amount of pressure. Otherwise, you'd have frozen ice, right? But it was liquid water, and it's consistent with liquid water, I should say. And so if there's liquid water down there, it means, number one, it's under pressure. Number two, it's going to be at the point where the water temperature might be frigid. It could be below zero, but still be liquid as long as the pressure is high enough, right? Now we're playing with triple point of water thing, which is a whole other aspect of Mars, okay? But if we talk about the water underneath that South Pole, there could be potential microbial life there. And we wouldn't even think that was a place to look, just like we would never have thought about looking at Enceladus, Saturn's moon Enceladus, or Jupiter's moon Europa.
Or Titan.
Never thought, or Titan. We would never even considered the possibility that there might be life in any of these places had we not found those sulfide chimneys in the bottom of our ocean where chemosynthesis shows a plentiful ladder of life surrounding them. So clearly, underneath the Martian surface, there might be such a thing. The additional thing that adds credence to this is a lake here on Earth. Do you know where that lake is? There's a lake that actually simulates what we find on Mars. You know the lake. I know you do.
It's at the South Pole.
You got it. Lake Vostok. Yeah. That's right. At Vostok Station. And that lake is miles below the Antarctic surface. It's been out of reach of air and land and air, well, basically sunlight for many years. I'd say, I don't remember the exact number, but I think it's been close to 1 million years it's been out of light, okay, and out of the surface. Yet you go down there, they drilled a hole, the Russians, they drilled a hole down to Lake Vostok from the surface, a deep hole. And when they got down to there, they were astonished to not find a dead water zone. They found over 3,000 different varieties of life thriving down there. And what happens when life forms? Well, life forms and it uses energy. It creates energy somehow. Well, it creates energy through some chemical synthesis, right? Maybe it's feeding off something. But then it exudes waste. And that waste goes back into the system and then gets recycled and comes back again to form potential food for something else, right? Right. Those are called the cycles, right? There's many cycles. There's methane cycles, carbon cycles, water cycles, oxygen cycles. You got cycles of all types. This was happening in Lake Vostok. It's a closed system. And that was the key. Wow, we have a lake on Earth that's out of touch with everything for this long, miles under the Antarctic ice, yet its thriving community of life is there. And the reason is because it has its own internal cycles. So if it happened here, it can happen there, and it probably has. That's the point. So maybe now we have to consider that there are more exotic forms of life out there. We didn't know some of the species that are in Lake Vostok. It's like, hey, it's like a field day for people that are trying to study life, right?
Right. So, Mark, when is your second observatory going to be all set up and ready to go? And when are we going to see those three-dimensional images of the moon?
Well, as we speak, I'm getting imagery from there. The metal siding is going up now. I'm looking at they're putting in the posts now that are going to take the roof off because it's now a sliding roof observatory. The entire roof is going to slide off and expose the telescopes within. Notice it's plural. There's going to be our telescope in there, the one that we bought especially for that observatory. And thanks to a GoFundMe, by the way, that was really successful. Totally humbling and surprising. I got so much support. And then there's another pier that's going to go in with another permanent telescope in there. And that's going to be another streaming group that's going to come in and utilize that and basically, have that pier that they'll use with me. And then we're going to put a third one in there for another telescope that is yet to be determined. And so it's going along well, and I expect the building itself will be done by tomorrow.
Wow.
And then I have to send equipment out there and start testing the throughput for the internet and so forth. I know what the internet throughput is out there in the desert. I have throughput out there, but I'm going to have to streamline some things because it's actually slower than it is here. Okay, about 3 times slower. So I have to, speed up my data stream coming back from the observatory 3 times faster, and I got to figure out how to do that. But it's a great challenge to have.
Yeah. Well, Mark, I have to tell you, I'm so happy that you joined me here today. I really am. I hope we get a chance to talk again in the future. I hope we get a chance to talk many, many more times, even if it's not on the podcast. I just like hanging out with you, and I learned so much. I learned so much from just being around you. I really appreciate it.
Well, look, the nice thing is you understand everything I'm talking about, and if I can't relay it to the audience, you will. So I think it's a good pairing here. Good idea. Thanks, Richard. It's really cool being here with you.
I really appreciate it. And I'll be back in just a few minutes with some afterthoughts.
You are not alone. Thousands of people all over the world have sightings of UFOs per month. MUFON is the place to report them. Since 1969, MUFON has been investigating UFO reports and providing this information to the public. Our aim is the scientific study of UFOs for the benefit of humanity. Support UFO research. Join MUFON today.
You are listening to the official podcast of the Mutual UFO Network.
Marc Dantonio reminds us that no matter how far afield we may travel in speculation, it is more important now than ever, in the midst of all that is happening, to remain grounded in truth and science. When we look out into the universe, we see all of the same stuff that we are made of, and we cannot help but wonder if there are others out there staring into the abyss, pondering whether they too are alone. One thing is certain: humanity is just beginning its journey into the cosmos. I have included a link to Marc Dantonio's book, The Populated Universe. Life in the Universe May Very Well Be the Rule and Not the Exception, in the show description below. I've also included a link to Mark's YouTube channel, The Sky Tour Live Stream with Marc Dantonio. Thank you once again for joining us. Please remember to like and subscribe. We'll see you next time right here on the official MUFON Podcast.